In this video we're going to be talking about shifts, how do graphs move, and specifically in this video we're just going to focus on root graphs. Shifts can happen with all different kinds of graphs, but specifically in this video I'm just going to focus on square root graphs and cube root graphs and how we can describe their shifts. So to start with, let's just talk about shifts. Shifts can happen left or right. So those are our horizontal shifts, left or right. Left would be usually negative values, and right will be movements of positive values. And so you'll see shifts described differently in books. They'll either talk about a shift left 3 units, or they'll say it's a horizontal shift of -3. And both cases are talking about the same thing. So I'll try and describe both as we do this today. With vertical shifts, we have an up and we have a down. And hopefully you know that up will be positive values and down will be negative values. And so similarly, you will either hear or read shifts described as down 3 units or vertical shift of -3. Either one, same exact thing. Alright, so let's try and do a couple here. Let's see. Get a new graph going. So let's do a square root function first. Let's say that we're trying to graph square root of x minus 2. So if you've already seen my videos on graphing square root functions and cube root functions, it will help you a lot. Otherwise you might be somewhat lost here. I would encourage you to watch those first. So to graph a square root function, we know that our vertex is going to be at 2, and since k isn't listed there, it's implied that it's 0. So there's our center at 2, 0. I know that my shortcuts for graphing square root functions are up 1 over 1 to get the next point, and then from here I go up 1 over 3, and from there I go up 1 over 5. 1, 2, 3, 4, 5. So not quite on the graph, but there it is. Alright, so that's basically the idea of our function here. And we're always talking about shifts from an original. So you'll either see it described as shifts from the origin, which I think makes a lot of sense, or you'll see questions like shifted from the original graph, or the most basic graph, the square root of x, which will always have its origin or its center at the origin, excuse me. So I think shifted from the origin makes more sense than saying shifted from this graph, but there are lots of different ways we could describe it. Alright, so if I was to graph that original, let me see, make the original in red. Let's start at the origin, go up 1 over 1, up 1 over 3, and up 1 over 5. 1, 2, 3, 4, 5. So as we can see here, all of our points have the exact same shift, and the shift is in your h value and your k value. So this is a horizontal shift of +2, and it's a vertical shift of nothing. Doesn't get shifted. So we move to the right. That's another word. Right 2 units would be another way to describe this. And so the original vertex got shifted right 2 spots. Well, that's true. The next point from the original got shifted right 2 spots. That's true. Point after that got shifted right 2 spots. Still true. And the point after that got shifted right 2 spots. So all of the spots on the graph, an infinite amount of spots or points on your graph, are getting shifted the exact same shift. They're all getting moved over to the right 2 spots. And so we could either describe that as a shift horizontally +2 or a shift right 2 units. Let's do another one, see what happens. Let's do one more square root and then we'll move on to cube roots. So a little bit fancier here. X, let's do plus 3 minus 4. So we know our h and k values. H is negative 3 and our k is negative 4. That's also our center or vertex of our graph. So negative 3, negative 4. Shortcut is to go up 1 over 1, up 1 over 3, and up 1 over 5. 1, 2, 3, 4, 5. And it does continue to go past that, obviously. And I'll leave that up to you to figure out what the pattern is after that. But always to begin with, up 1 over 1, up 1 over 3, up 1 over 5 will give you usually enough points to answer any question you'll see. So we know that the original was right here. 2, 3, 1, 2, 3, 4, 5. Nope, right there. So every point on that graph got shifted, supposedly 3 units to the left and 4 units down. Well, let's check it out and make sure. So we have a horizontal shift of negative 3 units, or we just say left 3 units. And we have a vertical shift of negative 4 units, or we would say down 4 units. So this point got shifted left 3, 1, 2, 3, and down 4. Yep. The next point to left 3, 1, 2, 3, down 4, 1, 2, 3, 4. Yep. Next point left 3, down 4. Yes. And the point after that left 3, down 4. So the shift holds up. It is this original graph shifted to the left 3 units and down 4 units. So that's how we describe our shift. Alright. So hopefully you're starting to get it. Let's do a cube root function this time. Let's say I have the cube root of x plus 1 minus 3. So if we remember our cube root, let's do the original first this time. So my original is always just the cube root of x, right? So how did this get shifted away from this? Well, that is the same as saying from the origin. So we know that our vertex or center of a cube root is at the origin, 0, 0. And then the next pattern to find the other points is up 1 over 1, and then up 1 over 7. 1, 2, 3, 4, 5, 6, 7. And then working backwards, we go down 1, left 1, and down 1, left 7. 1, 2, 3, 4, 5, 6, 7. And there is our most basic cube root graph. So how does this function, this new function, how does it look different? How did this graph get moved to now be this function? Okay, well, we know our center for that is the opposite of what it looks like there. So our h value is negative 1 and our k value is negative 3. So our center is at negative 1, negative 3. So it looks like a shift left 1, down 3. Well, that's what our h and k values are. So it's a horizontal shift of negative 1, or left 1 unit, and a vertical shift of negative 3, or down 3 units. Well, if we go from this point and go left 1, down 3, 1, 2, 3, that holds up with our pattern of up 1 over 1. Let's take this next point and go left 1, down 3, 1, 2, 3. And is that up 1 over 7? 1, 1, 2, 3, 4, 5, 6, 7. Yep. So our pattern is holding true. If we take the bottom now, so we go down, or left 1, sorry, and then down 3, 1, 2, 3. And that still is holding up. And then this point, left 1, down 3. So did it go down 1, left 7, 1, 2, 3, 4, 5, 6, 7? Yes, it did. So again, our patterns are holding up. It is just this graph moved down 1 and left 3. I'm sorry, left 1, down 3. So every single point on this graph got shifted the exact same points. Let's do one more just to solidify it. One more cube root. See if we can make it fancy here. Cube root of x minus 6 plus 5. So I know that my center is at positive 6, positive 5. Positive 6, positive 5. And I know that I'm going to go up 1 over 1. And then up 1 over 7, so our point's going to be off the graph. That's okay. Down 1, left 1. And then down 1, left 7. 1, 2, 3, 4, 5, 6, 7. And so that's our original graph shifted from the origin 6 spots right, or a horizontal shift of plus 6 units, and a vertical shift, or 5 units up, or a vertical shift of positive 5 units. Alright, so there we go, talking about shifts of root graphs. Again, we can have shifts of all different kinds of graphs, quadratics, other polynomials, and you can check out those other videos if you'd like. But this was specific to root functions and their shifts. So good luck describing shifts of root functions.